Assalamualaikum and welcome back to my lecture. Today we're going to continue to the last part, which is the reduction of simple distributed loading. What is distributed loading? In many situations, a surface of body it may subjected to a distributed loading. It can be caused by wind, fluids, or the weight of the item on that body surface. The intensity measured in Newton over meter, and the distributed loading can be represented by a single resultant force, and the magnitude is the total area under that distributed loading. Now let's do example 4.23. For this case, we need to determine the constructed load for case A and case B. For case A, as you can see here, the distributed load is 400 pound over feet. As we can see here, the length of this beam is 10 feet. Therefore, the UDL on that beam is 400 pound over feet. Then we need to determine the force resultant on that beam. That means 400 pound over feet times by the length of that beam, which is 10 feet. Then we get our FR value is 400 pound. So this FR is 400 pound. Then we need to determine where is this location on this beam. Back to our question, our UDL is symmetry. Therefore, for distance from each side is x equal to total length 10 feet divided by 2. Therefore, the distance from each side is 5 feet. So we get our force resultant is 400, and the location is in the middle of this beam. For the next one, we have pin and roller, and UDL is triangle with intensity of W is 100x Newton over meter, and the highest is 600 Newton meter on roller support. Then we need to calculate our FR, the force resultant for this case. FR equal to area of this. Therefore, half time by the highest is 600 time by the length of this beam is 6 meter. Therefore, our FR is 1800 Newton. So we need to find the location of our FR. Back to the basic. For the triangle, this is the triangle. The center normally 2/3 over A from this side, or 1/3 over A from this side, and the total length is A. Then our X is, total length is 6 minus by 1/3 over 6. This is 1/3 times by A, so 1/3 over 6, and the answer is 4 meter from pin support, and the 2 meter from roller support. We done on example 4.23. Now we move to example 4.24. In this question, we can see the combination, and the UDL is 150 pound over feet. First, we need to find what is resultant force for the yellow shaded, and our FR is the total area of the yellow area, which is half time by 150, because this is 150, so the length is 6 feet, so our FR is 450 pound. Then the location is 2/3 times by 6, that means 4 feet from point A. That for our FR1. Next, we need to calculate for our FR2. For the green area, we need to find the area of that rectangular, which is 150 times by the length is 8. So our FR2 is 1,200 pounds. And the location for that is, we name as X. This is 8 feet for that green area. So 8 feet divided by 2. But don't forget to add another 6 feet from point A. Therefore, from point A is 10 feet. We have FR1 and FR2. Then we can get the total force resultant, which is 450 plus 1,200 pounds. The total FR is 1,650 pounds. So this is our FR, but we don't know yet where is that location exactly. Therefore, we take moment at A equal to 0 and positive clockwise. That means FR1 with magnitude of 450 times by 4 feet plus 1,200 for FR times by 10 feet to point A. Then we get our MR. A is 13,800 pound-feet. Back to basic, we know moment equal to force times the perpendicular distance. We know our moment, we know our force, then we can get our perpendicular distance D. Therefore, MRA equal to FR times by X, and X is MRA 13,800 divided by FR is 1,650. Then we can know the location of total force resultant, which is equal to 8.36 from point A. So this is 8.36 feet from point A. So we solve this problem. How about for the same question, but at point A, the moment given there is 100 pound-feet. Therefore, for the MRA, we take positive clockwise. That means FR1 times by the perpendicular distance times by FR2 times the perpendicular distance. Then we need to plus that 100 into equation. Then we solve as previously. How about if that moment at point A is anti-clockwise with the same magnitude? Therefore, for MRA, take positive clockwise. That means 400 for FR1 times the perpendicular distance plus FR2 times the perpendicular distance. You need to minus by that magnitude.